Cool. Hey everyone, are you having a good time? Okay. Anyone in the back? You guys having a good time too? Nobody? Okay, fuck you.
That guy's awesome.
Cool. We're about to hear a lecture on designing free hardware, right? So this sounds like it's going to be a really cool talk. I'm looking forward to it. So take it away, guys.
Okay. Hi everybody, especially that guy back there, because he's awesome. My name is Mog. This is Tim.
Hi.
And like he said, we're going to talk to you today about designing free hardware or scratching your own itch with a soldering iron. That happened today. So I thought I'd get the stupid questions, the frequently asked questions out of the way. The first thing people always ask when I tell them about free hardware is, so you're giving me some free stuff? And no, nothing is free except freedom. So it means free as in speech, not as in beer. Then the next question people often ask is, so how is this different than anything else, any other electronics that you might have? And so you can break up electronics and really into a few separate categories. The first one is what I refer to as closed hardware. And it's not exactly what you would think. It's not like your toaster or something else, I would say. Closed hardware would be something like a DVD player that actively works against you and that you can't fast forward through previews because somebody somewhere hates you.
Region coding and everything else.
Right. Other limitations that you cannot change on the device that you paid for with your own damn money and use however you want. And so this kind of stuff is exceptionally bad and rates a 0% freedom on my scale. And then you have this kind of middle ground further up the chain with hackable hardware. And so, like, for example, the first thing I really wrote source code for that wasn't on a computer was my Dreamcast. Early on, some hackers found a way to get around when the system boots, it checks for a key to make sure that the games are signed by the distributors, and so that you can only run safe games approved by Sega. And very early on, people found that key, and overnight, everybody had started porting emulators to the machine and other things. And I was able to write hello world code and push code over the network and do lots of fun things with it. And then it was just great, and it really became my device. I was able to do anything I could want with it and things that the manufacturer never had intended for.
I went through a similar thing playing with the PSP when I picked that console up. I thought this was really great hardware and a great package, but I couldn't do anything with it without cracking it open and hacking it. And I got to a point where I could run Linux and I could run my own code on it, and that's kind of where I wanted to be with it.
And so with these kind of things, you can get about halfway there. I would, on the free scale, the freedom dimension, it's around 50%, and which is good for a lot of things, but we're not all the way there yet. So the next thing up on the list actually is what most people have been talking about this weekend at the convention is open source hardware. And so open source hardware is hardware, electronics, just like anything else, but it is licensed to you under a copyleft license so that you are free to modify the hardware. The schematics for the hardware are available. Often the Gerbers are available. Everything you would need to reproduce the device yourself is there, and you can make improvements and share them with the community. Everything is really there. And there are a lot of great examples of this. For example, the TV Be Gone, Mitch is here this week, and I think he even gave a lightning talk about it
Yes.
earlier. And they're really great. They cover just about everything, and so it rates really high on the freedom dimension at 90%. So that's an A for effort. But you ask, why doesn't it get all the way? What makes it different than what I would call free hardware? And the distinction is that most of the projects that are called open source hardware are currently being built with proprietary software. A very popular option is Eagle, which comes in a freemium edition, which allows you to build 4x3 circuit boards with 2 layers and so many routes, so many other limitations. But you can do a lot in that little sandbox. And because of that, so many people have just not cared because they can design their little circuit board. And by little, I mean they're great projects. Like the Arduino is an example of something built using Eagle and has taken the world by storm. But if you wanted to modify it, you're going to have to use this proprietary program on your machine. And so what makes free hardware different is free hardware is built from the ground up using free software or open source software. So there is a great example of this in the RepRap project. The RepRap project is built using JITA, which is a free software program that allows you to design circuit boards from scratch. And so, and I guess it really fits with the whole RepRap spirit in that you build the printer from scratch and you can replicate, and then you can go in and make changes with the software, all staying inside the freedom dimension. And so free software merits on the freedom scale actually just a 95. It's just a little bit better. It's not 100%. And the problem with free hardware is that really in all electronics, everything is still a black box. And so to get to what I would call freedom plus plus, you would have to have gone to the talk yesterday where he talked about printing your own circuit boards, not your own circuit boards, your own transistors. He gave a talk on, what was it, this organic carbon
Yes.
transistors, which are free because right now the majority of all electronics are built, here, let's go back, wrong way, preview. So the RepRap, even though everything on it is free, the schematics, you can get data sheets that give you in-depth information on all the parts. So you really would have all the information to do it, but the Atmega is a black box. The motor controllers are black boxes. Everything on it's a collection of black boxes that have great documentation about how to use them, but they are ultimately black boxes. And so it's just always moving into a further curve to get down to 100% free. And so I would say right now people have the option to hit 95 pretty easily. And that's what we're going to be talking about today is using free software to develop your free hardware. And so then after I've gone through this whole spiel, people say, who cares? This is stupid. Why? You're a freetard.
Eagle's easy.
Eagle's easy. And so my first stance is I go Stallman on them. Freedom, important. You gotta fight for your rights. And then I go, no, I really don't care. Eagle works. And so I go, okay, you're right, Eagle's easy, but there are problems. So there is two famous examples in the free software community where this has really bitten people, Java and BitKeeper. The Java people, I'm sure you guys have been following the news, Oracle has sued Google for implementing Java, which they gave to the world. And that's so stupid. It doesn't make sense. And all these people were building stuff on Java even though it really wasn't fully open. And people just didn't care because why does it matter?
They anticipated that they were getting something free.
Right. Because it was free as in beer, not speech. And that was the problem. And then a very similar problem with BitKeeper. BitKeeper was a distributed version control system. It predates Git. And it was used by the Linux kernel to maintain everything, and it was given to them for free by the company because they wanted to be a nice company. But then one day, somebody started reverse engineering it who was a Linux kernel hacker, and they said, nope, take our ball, go home. And so Linux was left in the dark without anything. And so if you don't own it, building your infrastructure on top of something is very dangerous. And so people should be aware of that, and that's one point I would say. And then the next one is, with the free software, what free software gives you an advantage in is that really the tools can be a lot more creative to fill certain niches. Eagle is great in that it does everything in a very straightforward steps, but it doesn't have all the crazy features that a lot of the free software tools have. And we'll get more into that in a little bit here. And then finally, there are limitations. Even though it's free as in beer, like I said before, there's the 4x3 4 inches squared, you're allowed to make your boards. You're only allowed 2 layers. You're only allowed so many traces. The vias are actually octagons. There's lots of weird issues with their software, and it's all on their terms. It's just whenever they want to give you a new limitation or change. For example, Eagle just changed all their formats for their file formats, and so everybody is having to upgrade their symbols over time to be compatible, and that doesn't really happen as often in free software because there's no reason we want to push people to use a new version of the software other than it's better. And so really that's why you should be free. And now that you've decided to be free, and I'm happy you've all decided to be free, there's lots of options. A really easy place to start if you play with Arduinos is a project called Fritzing. It allows you to easily rig up and pre-build your what you want to build with your Arduino. It allows you to breadboard up schematics and see that they're going to work. It has a nice user interface that shows off like LEDs, resistors, potentiometers. Allows you to just easily build projects and
It's all very
and document
visual.
them. Very visual, but it won't allow you to go. It makes it more difficult to do more complicated things in it. But it's a great thing to start with, and it's multi-platform, runs on Mac and GNU Linux. The next option, actually, I'd like to talk about is one called KiCad. It's a Qt-based EDA, and it's very popular, I would say. It's probably more similar to Eagle if people here want to, have a smoother transition. It's an all-in-one kind of setup. Your schematics are directly linked to your footprints, and everything kind of ties together. And it even has really cool 3D output. But I wouldn't recommend it because I don't like Qt.
It's an option, though.
It's an option, and another option is this project called FreePCB. I've never used it before because it only runs on Windows. It looks pretty though. I don't know anything more about it. It is free. Oh, Windows is not free, right? And that's why I know nothing about it. Supposedly, but there hasn't been an update on the Wine project about it in like 6 months, so I didn't really get that far. There's another one written in top of Java, and so it works on Windows, Mac, and Linux. It has some very cool simulation stuff if you want to do kind of spice things. It can simulate your circuit and show how things work, and it also has EDA tools. It's a nice tool if you're big into Java, I would say. And then finally, we have the best tool,
One we use.
the one we use. And that's why it's not why it's the best, but it's why we use it. And it's called JITA. It stands for GPL Electronic, I forgot what D means this time.
Design.
Design.
Automation.
Automation. And it's pronounced JITA or Jetta.
Yeah.
Jetta.
Mostly depending on which side of the pond you come from, it sounds like.
Right. British people tend to say Jetta. Here it is. This is the schematics editor. This is a schematic we built. It allows you to just like all other schematic editors, pretty standard. Here's the PCB footprint editor and layout. And here is a Gerber view of a partially finished project here. And so the advantages of JITA are that it's built in the Unix style philosophy, and that it's so each part of JITA is a separate program that you can chain together to do your project. And so it's several different programs, and you run them all in sequence, and you get your build. And so it makes it really easy to have a make file that says, take the schematic, get the net list, take it into the layout program, get the layout, get the Gerbers, send it off to the factory. And so that's really nice. And like I was saying, so it's easy to segment the workflow. So in particular, in most of our projects, I will do a lot of the work on building the schematic and figuring out what parts we need to use and whatnot. And then I will, while I'm still working, I will say, Tim, we're going to use these parts,
Right.
Start building footprints for them, and start thinking about the layout of the board while I spend all my time doing this, so we can really get a whole man month in less time.
As soon as he's done with that, he can send those files to me that I can then actually nail down the PCB design as it's finished.
Right, and he only really needs to look at the output of what I've done generally, because it's all he needs. And so it really is good if you're working with a team, especially because it allows you to break up the work. One of the other advantages I would say of it is the file format for all of the different parts of JITA are just text files. And so one of the nice things is you can change them outside of the GUI. You can go in, just open the text file in a text editor, change a comment. You can add comments. You can just move things around easily in there.
There are use cases where it's almost easier to do it that way than.
Right. There's things like we worked on one project and we wanted to resize all the through holes so that they had the same drill size.
You
and so
just
we didn't
find
have
replace,
different drills.
yeah.
Right. And so we did a search and replace, and all the drill holes were the same size. I'm sorry?
With JITA
Do what?
simulation.
Simulation? Yes, there's spice tools in JITA. I was about to get to that. So because it's all text files, it's version control friendly. The diffs you get when you do a commit of a project into the system, it actually is just a diff. It's very straightforward. And one of the other nice things is there are actually several scripts people have written for JITA that will build standard footprints for you very easily. So you can say it's a TQFP with this kind of pitch, and it's 32 pins, and then it goes pop, and you got that footprint, and you're done. And there are lots of other generators that can do that kind of stuff. File formats? There's been some work between KiCad and JITA to try to standardize between the two of them to have an interchange, but that hasn't really taken off yet. And there has been some recent work now that Eagle has switched their file format to an XML format. People are currently trying, there's actually a lot more work in the KiCad community to port that, and then I imagine once that's done, JITA can just take that code and then import Eagle XML blobs. There are some file formats that are very interchangeable that JITA can work with. The standard Gerber format, the RS247, I can't remember the exact name, its viewers can open those files very easily, and there's some other formats that different things can open each other up. One thing that's nice about JITA, it's actually a very old project. It's started in 1998. Was its first public release, and it doesn't have lots of new features. The most crazy new feature that I know of that has happened fairly recently was they added support for, there's a preview format so that you can see what your PCB will look like, and they added in making it show the solder mask in different colors. And that was a big update. So it's not dead, it's just everything you really need is done. There are some pretty features that people are still kind of working on, like 3D OpenGL output, so you can look what it's going to like physically fit in, but that you don't really need that. It just is pretty. And in term with this depth, so the JITA actually, like I was saying, is several different programs. So there's SPICE, Wave Analysis, Verilog Simulator, Electromagnetic Structural Analysis. There's Gerber Viewing. There's just tons of different small programs in this whole suite of tools, and so you really can do just about anything with it in hardware. And the community mailing list and the IRC channel where people hang out with they've done a lot of this stuff, so they can help you out and using these tools and getting what you need done.
Seen some very mature projects come out of, very professional projects come out of this, not just hobbyists. Yeah.
Right. And so now you've decided to use JITA. It's awesome. You gotta go where to go from here.
Where do you start? You want to keep moving the slides though?
Yeah, I'll move them for you.
Okay. So first step is having an idea, and that's kind of you're going to have something you want to build, some project, some problem you want to solve, whether it's something that's going to spy on a spy bus for you for your own learning, for your own projects, or whether you want to have an end product that does something, or in one of our cases a learning kit. These are things that you could do out of this. So you have some idea, and I really find it's great to look at, don't worry about reinventing the wheel. if you're not the electronics guru, you can look at what other people are doing. Take the time to learn those things first. If you don't know how a resistor works, there's only so much these kinds of programs can help you with.
Right.
But you can go to other people. You can build small teams. You can work together with stuff, and you start to build a prototype. You find something that actually works. When you put it on a breadboard, stick little wires in, get something that's going to work. And so now you've built this prototype. You've got this thing that works. It blinks the way you want it to, or it does the thing you want it to do. You've done this. It really hands-on kind of prototyping is a great way to start. And this is something that Fritzing as well, I'll go back to. This is sort of their level where they start at least.
Right, that you can do all that.
That you can do all that in their
in
software.
theory, in
kind
software.
Of, yeah. And then once you've got that working, though, you're going to build a schematic. And that's going to tell you exactly where the connections are made, what's actually going on, what components you're using. I do understand all this, but I've left a lot of that work to Mog, so he feels like he's doing something.
It's the really important things about the schematic is so every step in hardware, every time you fail, causing a time in the mean times between failures can be weeks.
Yeah.
And at least for me, I come from software. I'm much more happy with minutes. I like things to fail early and often, and then I can move on and fix them. And so with the schematics, I find are most helpful for is making sure that you've dotted all your T's and crossed all your I's so that everything is correct.
Right. If you're waiting till the PCB design stage for that kind of troubleshooting, you're going to have nothing but headaches, because then you've got to move whole components around and reroute traces.
Right. And so when you do the schematic, you go through every data sheet, check all the specs, make sure everything is within spec, and then once you've completed this, the next step is you're going to go into PCB.
Then you're going to actually create a physical path for everything. Everything has to have a layout.
Right, but the nice thing is the step between schematic and PCB is there's a script in JITA that takes your schematic and builds you a very good net list that shows you where all the connections should be. And how they should be. You can mark traces being power traces or signal traces, and so then someone like Tim can go and route.
And it's almost, I will say as a hobby, it's almost fun that you can sit there and you work with a net list and you see all the connections in PCB that you're supposed to make, and they're just logical. And then you start filling those in the program, and you have a set of they're called rats. Those are the logical connections, and you work through these rats and tick them away, and I get to tell him, I was like, oh, I've only got 10 rats left, oh, I've only got 5 rats left,
And the unfortunate thing is, as the rats become less, they become exponentially harder to route.
1 or 2.
So one more dead is a glorious moment.
You get to those last 1 or 2, and then you got to back up some. It's like, but I've got 10 left. Oh, but you had 2 yesterday. Yeah.
Right.
But the process of making sure everything isn't overlapping, that you have the tolerances, you're still looking back at your data sheets for what you can and can't do. You'll have some components that say, you can't throw any signal line underneath my package, or I'm going to destroy it. So you look for those things, and you're saying from a physical level, how is everything going to fit together, and where is it electrically connected?
Mm-hmm. And if you're not a perfectionist and you can trust your computer, unlike Tim, there actually are auto routing tools in JITA, and you can use the DRC definitions to help you route these traces without having to do it yourself.
Yes, I'll admit the auto routing ability of JITA is very reasonable. I'll put it that way. If you're doing something small, definitely just click the button. You're done. Yay. There are times I'm going to be honest. I don't understand why it routed something over here, and then back and through like 8 vias.
6 layers.
Yeah, 6 layers. But there are still, and that's some of it's on us learning the tool, because there are still options within JITA to tell it. Well, it's only this many layers. Well, I want you to use this style routing.
Right, the auto router is very friendly if you feed it the right DRC rules and you feed it how many layers you want, And you can even select just a few of the nets. You don't want to route all the routes, just some of the routes, and
Yes.
it will do all this for you. And it also includes a auto placement, so it can move all the footprints around for you to what it thinks would make most sense logically.
Yes.
So if you have an LED connected to a resistor, it's going to move the LED and the resistor close together off in a direction.
So now you've built a board and you've designed it, and you can do all the little finishing work.
So yeah, you're
Right,
done.
you've got-
You have a board.
This is an example of the output we're talking about when you can do a simulated print of the board, so it's kind of pretty,
Yep.
but
But that's not really real.
no,
So.
there's a lot more to do after
Right.
this point to go to an actual product, to something you've done. And that's sourcing components. So even if you've already gone through the process when you started to pick out, oh, I'm going to use, a 555 timer and I'm going to use a 4017 counter, we still, well, okay, where can I actually buy 100 of those right now?
Yeah, today.
Today. Where can I buy those? And what's the cheapest price I can get? And, so
Yeah, if you
here's
want
the-
100 of them, sometimes you have to look a little bit.
Right. But there are these great places: Mouser, DigiKey, Element 14. There's a lot of little electronics design, electronics component shops out there on the internet.
And they're all very
Yeah.
good about when you search them, you can see how much parts are going to cost and what quantities they break in price. So, for
Right.
example, on this project, we bought, we needed 8,000 10K resistors, but it was actually half the price to buy 10,000 of them instead. And so we
Right.
have 2,000 10K resistors lying around.
Yeah.
Another good place to, there's a search engine called Octopart, and it's really cool because it searches DigiKey, Mouser, and others, and it will comparison price them. But usually the one kind of downside of it is it doesn't really comparison price in quantities. So, but
Right.
if you're looking for a one-off, it's very nice to just see where is this one the cheapest, and also it'll tell you if it's in stock.
Just as an aside to Octopart as well, it's not a bad place to look for the data sheets for a if you know already which chip it is you have sitting there, you can kind of type it in. It's a search engine designed for the electronics world. So
And eBay. There are
Yeah.
crazy
You can get-
Chinese people out there who want to sell you LEDs that they found off the back of a truck in millions of quantities.
So then finding a board house. There are some great options out there. The board house is what's printing your PCB for you, assuming that you aren't going to etch one for yourself.
Yeah,
but
don't etch. Boards are so cheap.
They're cheap and getting cheaper. Yeah.
There are some that we have used and some of our friends have used. In particular, we've had really good luck with Seed in the past.
Yep.
We've ordered several different boards from them, and they come fairly quickly. I think the slowest turnaround we had with Seed was about a month, and the fastest was probably 2 weeks. They do kind of batch processing, and so does Dorkbot. But recently we found this one guy. He has a website called hackvana.org, I want to say, or .net. But he actually doesn't have really anything up there. I met him on the Freenode. He was like, "Yeah, I live in China, and I can make you PCBs." I was like, "Really? I like the sound of that."
Yeah.
And he gave me a good quote, and we got a lot of PCBs from him. And the turnaround time was 1 week. They were fairly cheap. He has some kind of sketchy problems in that he doesn't have DRC rules. He says the board house...
The DRC is the tolerances between how small a line you can build, how small a trace,
How
and
far apart they can be.
they can be, that kind of thing.
Yeah,
Correct.
design rule check. But yeah, he was like, they make cell phones, so really, really tiny. Don't worry about it. And if it fails, we'll give it to you for free. Don't worry about it. So
Did we mention that he met him on IRC?
yeah, he was just in Pound PCB. He was like, "Hey, I hear you're making boards." And I was like, "Yeah." But I would strongly recommend any of y'all find him, give him some
Yeah,
business.
we
He's
got
awesome.
business from him. It works.
And then
So
finally,
one of the
the
one
last
of the
step.
steps.
is you gotta chain him to a table, and then, Panda Express, give him some food, make him feel at home.
Doing hard labor.
And so yeah, this is us sorting tons of PNP and NPN transistors right now,
Yeah.
and it's really boring.
Watch a movie, kind of sit back, package.
And then this is the final assembly,
Yeah.
doing all
Getting
the
them
boards and
wrapped.
packages, and
You can see one of our recent projects here, and they're wrapped like meat.
Yeah.
That was the idea. So we had to shrink wrap that, but we didn't have machines to do this. We were just starting out, so it's like
and we didn't know the proper way to do it until right
Yeah.
after we finished.
Yeah.
A friend of ours used to work in a meat market, and he was like, "Oh yeah, it's real easy. You just need hot coat hanger and this other thing, and it's easy."
Yeah.
And it takes like 10 seconds to do one, and we were like, "Oh."
Meanwhile, I'd spent days with a heat gun.
It was very upsetting. And so then, what's next?
Yeah.
Collect
Something,
some underpants.
and then profits.
So yeah, the big thing is
You've
that
created your project. It solves your task. It's a benefit to the world.
in this
it's-
case, it's you wanna
Yeah,
describe
so
what the project was?
we didn't actually touch on this. This particular project came out of an idea of wanting to teach soldering, and to say, I want a kit to teach soldering. I want them to actually have produced something when it's finished and done more than 3 connections. So there's something substantial you sit down with, and something that does something when you're done, and that's sort of a tank of a design. You don't have to worry about what goes into it. And I'd seen a couple projects like the electronic dice. It's a fun little engineering problem when you're starting out. So I'd gotten advice from other people about how to build these, kind of tweaked it to what I wanted it to do and how I wanted it to behave. And that's how this design came about. And
And then
What
the
am I
other
doing?
nice side of it is that that my goal out of it was to provide a very good example of all the output of all these tools. And so
Right.
we've also published all of the it's open hardware, or free hardware as I would call it. All the schematics, Gerbers, footprints, the PCB layout, the make file we use to go through and automate this whole process. Every little bit of it is out there.
And I'll admit, before starting some of these projects that we've been working on, not just this one, I had used Eagle before, and Eagle was really easy as for a hobbyist. That was great. And he's like, no, let's use something open source. That's awesome, freedom. And I'm not gonna lie, it was hard to learn some of the stuff going into Jita. But now that I know it all, I don't want to say I know it all. Now that I know how to use Jita to finish a product, I'm so much happier with what I get done. In that same kind of anal, you did everything yourself way. I'm not worried about footprint generators and stuff like that. I'm going to build the footprint myself. I'm going to finish this myself. And it gives you those tools, and it gives you that really
Would you say it's like a
romantic
akin to like
relationship.
learning Vim or Emacs, and that
Yeah,
it's very
exactly.
high
Like a lot of other
overhead at
open source.
first, but
Right.
then once you get into it, it's faster
powerful.
and much quicker to get what you want done.
Yeah, definitely. So that's we got a finished product out of it, and we hope to do more. So
Yes. And so this is pretty much what we have. And we were wondering if anybody had questions, comments, anything they wanted to know more about these different tools. The talk is available online at that web address. You can download the PDF. For some reason, right now it's 100 megabytes. I don't know. I'm gonna make it smaller at some point.
yeah.
Yeah, if anybody has any questions about the tool chains, or why we
Free
did what we did,
hardware.
or etc.
Hi, great talk. I went through something similar just recently. And one of the things I haven't been able to figure out is what impact pin type has when you're using Jita. It's got to have some kind of downstream flow to PCB, but I don't understand what that is. I mark all of my pins as passive right now.
Right. You can define your pin types and your trace types, or really in the schematic part, you can define different traces so that when you are in PCB, it can be marked as it needs to be a fatter trace or a thinner trace. For most projects that hobbyists would do, like us, we're working at very small megahertz, very small power. The standard level thickness of trace is going to be fine for anything you're going to do, and you don't really need to differentiate it. So like on this board, for example, every trace we did as the just ginormously fat.
Yeah.
One of our kind of other goals with this board was that the board is designed so that it could be chemically etched easily.
Yeah.
We had a person
One
that-
layer. It's
Right, it's all one layer. Yeah,
there.
we never did any staples. Or needed any spots where another layer would be needed, and so that's nifty. But yeah, that's the purpose of the pin types is you can make it so that on the next step on PCB you make sure you don't make a mistake by, I don't know, routing like a radio signal through way too thin of a trace or something like that.
Signals to the power type
Yeah.
of
Yeah,
thing.
I think it's a great example where PCB and GITA as a whole, as a tool chain, works really well, surprisingly well from an enterprise mindset. And so, yeah, as a hobbyist, you don't really think about it that much. You're not worried about those tolerances, but the tools are available to you.
Well, and even
So-
if you were, you're aware of your whole project. But if you
Right.
were handing this off to somebody else, he might
Right.
not realize that part is doing this function and needs to have this tolerance to work. And so it's a way of just more documentation in your project at the source file level.
You say that pin is a power pin, they know they need something thicker for a trace going to it for
Yeah,
providing power.
okay, thanks.
Thank you.
Okay, I'm curious, how much are you paying for like a 2x3 double-sided board with a silk screen and solder mask?
2x3. So this board was how big? It was
It's 3.5 by like 3.5.
So yeah, this board was 3.5 by 3.5. We ordered 100 of them and had rush shipping, and it was I think $169, and 40 of that was the shipping, and so
Yeah, 'cause we wanted it.
It's very cheap.
too.
But the other nice thing about the Hack Vanna guy is he is a cell phone, or the person in his board house does mostly cell phones, and so they do 2, 4, and 8 layer boards, I think. And so he doesn't care.
So if you need a multi-layer board, he can handle it.
It's not any big deal to him, yeah, to add more layers.
Okay, I'm a total KiCad person because I just transfer to that, and I see no reason, like I can't see any reason why you guys choose Gita over KiCad because it's really easy to use. I use Altium and like DXP before when I was in
Right.
university, and after that I heard about Eagle because I'm from China, so obviously people in China don't use Eagle at all.
Right.
So I heard about Eagle and
What do you guys use in China mostly?
I said Altium.
Oh, just mostly
Altium.
Altium. Okay. I
Yeah,
was
yeah,
curious.
but the very previous is called Protel. Yeah.
Okay.
And well, so I really want to know because I don't use Gita before. I saw the GUI and I give up. Yeah.
That's a common term. I mean, common
Well,
thing I've heard.
Yeah, but be aware that I was electrical engineering major, so I totally used way more complicated stuff like I think it's called PAD, PDS. PADS, PAD, or whatever. So cadence, yeah. So anyway, I want to really know the difference between Gita and KiCad and why you guys choose, Gita. I'm aware Gita can do simulation, but that's the functionality most people don't use, right?
No, exactly.
We don't even use it.
Right,
yeah.
we don't use it because we don't usually do analog that is that temperamental that we would want to make sure that it would work before we'd actually produce.
Right, right.
I would say the biggest difference between Gita and KiCad is that I think Gita is built much more as several different projects, whereas KiCad, everything's tied together. So like, I have a schematic file for a part, or a symbol file for the part, and then there's a schematic file that eats the symbol files, and then those are just tangentially linked to the footprint files. And so it's easy to change each one of these parts individually without affecting the others. Whereas most of the stuff that I see in KiCad, everything is kind of lumped together. And I'm not necessarily saying one is better than the other, but I just prefer to have each thing be its small own little bit of the world. Because, for example, I know nothing about routing. I get very frustrated in that I finish all of I need to do, and Tim has the last step in the process, and then I'm just finish,
Yeah.
route. But the nice thing is I don't feel I need to know any of that because it's easy enough for us to segment this work in that way. But there's nothing in KiCad, to my knowledge, that you can't do in Gita or vice versa, except for maybe some of the simulation and like Verilog, some of the more features that aren't part of the core feature set.
Yeah. Some of our decision to use Gita over KiCad was mostly personal. Yeah. We're not here to say that KiCad's actually a bad program, but
Yeah, so I still so I want to clarify that. So I've been using KiCad for a while, and it's actually you can totally separate all the.
No, I'm aware people can work different, I mean, apart from each other. It just seems to me that the majority of people that are using KiCad use it in the same way that I see people use Eagle, and that they have like they have a problem in their PCB. They click on a footprint and then they edit the schematic, and then that changes something in their other design. Whereas when we have hit a problem like that, I go into the schematic and I make the changes, and then I say update, and I get basically a diff that I can send to Tim, and then diff can apply it. He can apply the diff onto the PCB in its own subsection away, and then he can integrate those changes back in. And I just feel like that's a better, for integrity of the project, is a better way to work. And I think that workflow is more defined in JITA than in KiCad. But I only really used KiCad for a brief period before I decided that I liked JITA better.
Okay, thanks.
I was wondering if you could elaborate a little bit more on the difference between JETA or JITA compared to some of the kind of industry standard or the higher level stuff, you know, where the shortcomings might be with respect to high-speed designs or RF designs, stuff like that. Something that if I wanted to kind of grow with this software into kind of more complicated designs,
Right.
where might I hit a wall?
So first off, I guess I should have said this at the very beginning of the talk, but Tim and I are not EEs or even CPEs or even college graduates. So you're going to have to take this with a tiny grain of salt, what I'm about to say. To my knowledge, PCB does not have tools for auto-routing traces based on megahertz delay and whatnot, so it would be difficult to do something like that in JITA. But in saying that, I have seen some people who are using JITA doing complicated things like that. I'm not actually aware how they're doing the math to figure that out. I'm sure they're not just eyeballing it and be like, that's good.
Yeah.
Math's not too bad, I mean.
Tools to keep bus traces the same length.
Right. No, I know there's tools to keep bus traces the same length, but when you're trying to route a signal to have it arrive at the same time based on different megahertz clocks, and you have to wind the signal
RAM
around
winding,
because you're accounting for the speed of the electron through the path. To my knowledge, PCB doesn't have something for that, but I have
It
seen
doesn't have anything to make it easy.
Right, to do
but
it
you could
automatically,
still
like some of the Pro
create
tools do.
those routes. Yeah.
Sure. And you haven't run into any multi-layer designs. Have you done any 4-layer designs with JITA, or know anyone that has?
I've played with 4-layer processes. I haven't produced anything yet on a 4-layer. I think, and I've seen the auto route. The auto route will make those decisions sometimes when you let it, and I've seen it just produce this 8-layer monstrosity because it could.
Well, and JITA doesn't have a layer limit. You can tell
Right.
it to keep making more layers. You could
Would you like to
theoretically
use a 64-layer process? Sure.
1,000 layers. Board's gonna be that thick. It's gonna be great. It'll be tiny though, but like that move around.
Yeah.
Oh dear.
But that's not a limitation there, at least.
More recently, I've had friends and family who do work in board houses, in engineering jobs for real, that I do try to now say, like, hey, look at this neat toy I'm playing with. How does it compare? And I will get some comments. It's either condescending or, yes, that is a neat toy that you're working with. But they haven't come up with anything that I couldn't do in that they do in their bigger programs. Yeah.
Cool, thanks.
The only other big thing I would say is that some of the other tools now are starting to have these footprint on demand services, and there's nothing like that in JITA. There are stores where people have put up their footprints like ours. Like we have all of our footprints online. Anybody could take them and use them if they wanted. But
Yeah, I'm with you with the anal.
right, nobody wants to
Right,
use anybody
right.
else's
It's like, this is
footprint.
Because there are so many instances where it's a TQFP,
Yeah.
but the pad length is actually a little bit wider.
Right,
a little bit
right.
shorter.
Well, you want a little bit wider because you have the space for it. Exactly.
I've seen some people route silk over pads as well. It's like, what are you doing? Anyway.
Do you guys have any experience with places that will actually mount the components for you and what that costs?
That's
if
actually
you're doing like really small, BGA type of thing.
That was the step about chaining me to a desk.
Yeah, that's you call me and I'll hit him.
So you would actually do things like that by hand. I mean, if it's
Yes.
You can for a certain pitch with BGAs. There people are hot plating them.
Yep.
But
Okay.
more realistically, there are services that will do that level of manufacture or assembly for you.
Have you guys done any of that?
We haven't had anything where we had them assembled because I have Tim. But one that's a new service Seed actually just started offering.
Yeah.
They will do assembly for you, and they can give you a quote based on how many components and how difficult it is. And they have even gone as far as they'll even sell it for you. They'll never ship you a product. You can drop ship directly from them. You just give them everything and trust that the Seed guys are awesome because they are.
Yeah.
But
Cool. All right. Thanks.
no problem.
Hi.
Hi.
I think you started with the schematic. Have you thought of going to, let's say, a higher level of abstraction like Verilog or VHDL? And if so, why don't you switch to that? I mean, I think what you are doing is that you are coming up with a schematic, and then you decide what are the discrete components, and then you build a PCB, and then you solder those components, right? So I'm just trying to understand if you go to a higher level of abstraction like Verilog, how we do the whole flow, using GIDA.
So with GIDA, there is a path for using Verilog as your symbol language. I haven't personally used it because all the projects
Yeah.
we've worked on are so simplistic that I wouldn't even begin to think of using Verilog to define the relationships. But
Microcontroller, done.
yeah,
Sorry.
exactly.
I know those tools. I agree with him. I know those tools are available. I've seen them in the chain, and I played with them one afternoon, and I don't know what I needed them for.
Right.
But-
And at least personally, I find
Yeah.
for the level of complexity we've kind of done, most of our projects are 8-bit microcontroller based. It's just easier to see where everything's going on a cleanly made schematic than to read through what is source code and Verilog.
So I apologize. We haven't actually experienced that.
If you're talking about the microcontroller, then you have the Arduino kit, right? So you can use that. Why going through all this pain?
Oh, why
Well,
would
we're-
we bother making this an analog instead of just putting down
This
one
one?
Arduino? Yeah.
That conversation came up building this kit. I felt this is all passive components because I didn't like, I knew we were packaging this ourselves. I didn't want to go through the process of programming every microcontroller we sent out and making sure it would work. And then when you ship it, and make sure that when they solder it together, it's going to work. The analog components were just so much easier, and I feel that this is going to be a tank. There's little you could do to break it, really.
And although I disagree with Tim at first, this is $1.54 cheaper because it uses this instead of an Arduino.
Yeah.
Or I mean, not an Arduino, but any app Mega.
But you're right. We talk about building microcontroller projects. Why not just use an Arduino? We're not just talking about a fun little robot on your desk or a blinky LED. Arduino's great. You can do prototyping with an Arduino. We're trying to get stuff that's smaller, stuff that does other things, more purposeful products that do a thing. And it's great that they're a microcontroller. We hope to open that up to you because it's open source, but we're not looking to build the next Arduino.
Right.
The Arduino's a great product. Just
Right.
use
We
that.
probably use the Arduino in the majority of our prototyping to begin with because it's such a nice little tool.
What are some of the projects that you have done, like applications that you can share with us?
So we don't like to talk about unreleased products, but since you asked so nicely, we've been working off and on for about 2 years now on a implementation of a two-factor authentication token.
Kind of like the RSA.
Like the RSA tokens.
Key fob. Yeah.
But we've had some issues with battery life. That's one of the problems where we're not
double E's.
We're not double E's. It'd be nice if we were, because then this wouldn't have taken 2 years. It'd probably take 2 months.
Yeah.
We've worked on an alarm clock that messes with you intentionally. So you set the alarm for 7:30, and then around 7:20, the clock starts to elicit odd behavior, several different ones. Like, for example, it can pretend it's daylight savings time, and you're messed up.
Display the
Or-
time in hex.
or time drifts by 13 minutes,
Yeah.
or several other things. That's kind of a funny one.
If you're wondering why, is I know at least myself and a couple of us, it's easy to trust your alarm clock and go, oh, I got 5 more minutes. And This was,
This would
we
make
saw
that
as a
not
solution to saying, it's like, well, you can't trust this clock. You don't know what's going on.
Right. You got to get up. And we built a reflow oven controller so that Tim doesn't have to solder everything by hand.
Right.
We've been working on that for a while, but don't quite have a finished design yet. But fun stuff.
Where can we buy your kit?
You want to buy it? Give me some money.
How much?
Lots of it.
You don't even want to meatstand.com?
Yeah, meatstand.com is our website. And if you go to the website, all the source is under this fossil repo, and it's licensed under GPL v3. All of our hardware so far has been licensed that way because I'm a freetard. But
Wait a minute. So you said you were doing RSA on discrete components like that.
no. Our RSA
No.
token is actually built off
RSA
an
is an example
AtMega
of a
328.
microcontroller project.
Sorry?
It's a separate project that we've done. It uses an AtMega 328 as the brain and just a 32 kilohertz clock to provide the clock and an OLED screen for the display.
And given the complexity of the RSA that I know, what is the speed, that you're
It's
getting?
actually pretty instantaneous. We use, I didn't realize it when I started working on the project, but there's an RFC, I wish I could remember the number off the top of my head, that defines a way of using a SHA-1. So you have a secret on your token, and then you take the time and that secret, and you SHA-1 sum it, and then you run an FNV hash to get a very small, like a 20-bit number, and then you display it as a 6-digit number to the user, and then you're doing the same thing on the server, and you just compare those two numbers. And there are crypto libraries for the AtMega system for doing this, and on the 8 megahertz one, it's instantaneous.
Yeah.
I never even took the time to measure it, and then you just go back to sleep.
Okay, then it's not RSA. It's
No, it's not.
No,
it's not RSA
it's a clone
specifically,
of, it's,
but it
we use
implements
it
the
as an
same
example
feature set.
of what the product is.
And it's the same system, or Google is using the SHA-1 system in their two-factor authentication system. I would say it's of equal security, given that in all of these systems, the only thing that really is protecting you is your secret on the token and in the server, and the algorithm. I don't think SHA-1 has been, or not SHA-1, but SHA-256 has been broken in such a way that it would make it any less secure than an RSA token.
Right. Right.
Right, the secure ID
Yeah.
token. But they don't, to my knowledge, they don't publish how they actually implement their random.
No, but it just
Right.
gets leaked.
Right, they lose millions of tokens somehow.
Yeah, we heard that it got leaked and we went, yippee. And then we heard that Google was doing something like it and we went, oh.
Right. One of the advantages of our system, and the same thing Google is actually doing, is we want you to be able to keep your secret on both ends, and
Right.
we don't want to hear from you. We want to give
Right.
you a device, and you keep your secret secret.
And if you lost it, that's your
Tough.
deal.
Buy another one.
Buy another, yeah.
Going back to GSkim, is there any utility in there to do a bill of materials automatically?
So you can do it in Gscheme, but what I find the better place to do it is in PCB. PCB has two nifty tools actually. It can produce a BOM, and of all all the parts you need, and then it also has the ability to produce an X and Y plot. So a pick and place machine could place all the parts.
That's really
Yeah.
handy because somebody gave our hackerspace a pick-and-place machine.
There you go. You can just assemble your board yourself, or assemble our boards.
We're looking for a project to use it
There you
for,
go.
so.
Awesome. Okay, I think that's
Sorry, Calgary Hackerspace.
Yeah, I think we're
cool. That's most of our time, but any other questions?
last question. You're gonna buy one, Matt, right now?
Okay.
Give me
Thank
some
you very
money.
much.
Cool.
Thank you guys so much. It was a great talk.
Bye.